This is the 6-2 warm-up, okay? So the first thing I'm going to do is write one of each of my equations at the top. The more you write them, the easier it is going to be for you to remember them. So write them out each time if you don't know them yet. So I'm going to do the a squared one. A squared would equal b squared plus c squared minus 2bc cosine a. So it's the opposite letters, right? Because those are the ones you already have, minus the product of those times the cosine of the letter that matches the original one. And then the angle would be like cosine A equals, it's the other two letters first, b squared plus c squared minus the letter that matches a squared over 2bc. We do this first one when we have side angle side. We do the second one when we have side side side. So those two scenarios are where you use law of cosines. Anything else, you use law of sines. So if I look at number one, what information are you given? Side, side, side. So I'm going to use the second one to find one of the angles. I'm going to say cosine. Now, if you stick to law of cosines the whole time, order does not matter. But if you're going to switch to law of sines, you have to pick the biggest one. So by habit, I just picked the biggest one. Biggest would be C because it's opposite the largest side. So cosine of C would equal a squared plus b squared minus c squared over 2ab. Correct. This is we plug in 7 squared plus 10 squared minus 15 squared over 2 times 7 times 10. And we're going to cosine negative 1 that whole thing. And we're going to make sure that we add in our parentheses after the starting parentheses from cosine. Close them at the end of the numerator, divided by, and then open them up again, or we're going to get an error. Second cosine, open parentheses, 7 squared plus 10 squared minus 15 squared. Close the parentheses, divided by 2 times 7 times 10. And I get angle C equals 122.88 degrees, because we're going to round it to 2 decimal places. Then if I am sticking with law of cosines, the order doesn't matter, but I'm going to just go to the next one. So I'm going to say A. Cosine of A equals, and we do b squared plus c squared minus a squared over 2bc. So 10 squared plus 15 squared minus 7 squared over 2 times 10 times 15. And I'm going to cosine negative 1 that whole thing. Again, making sure I put those parentheses in. And I get angle A, 23.07 degrees. And then to find the last one, I can subtract those both from 180. With extra time, you can also use the law of cosines on that last angle, angle B, but only if you have extra time. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8. I'll give you a half hour. I haven't timed myself, so I'll time myself taking it. If I need to adjust it, I can, but minimum half hour. Questions on that one? All right, 2, I've got angle 135, side B and side C. Again, these are going to get grouped in with the law of sines. So if you don't see that that is side angle side, and I know because it's one of each of the letters with one capital letter, right? So it's side, 2 sides in the capital letter, all different. That's side angle side. If you don't see it, you need to draw it out so you can make sure. If you tried to go to law of sines to solve this, you would not be able to. You don't have 2 of the same letter nor a way to find it. So something should stop you, okay? But hopefully you know what to just be able to identify, okay, that's side angle side. And if it's side angle side, I'm going to law of cosines. I got to find the last side. That's the first thing I'm going to find. So a squared would equal b squared plus c squared minus 2bc cosine a. And I get 4 squared plus 9 squared minus 2 times 4 times 9 times the cosine of 135. That equals a squared, so I'm going to square root that whole thing. And you could do that all in one step, or you could find what's under it and then square root the answer. It doesn't matter. Just be careful typing that in. I get A is 12.16. Sure. You're welcome. You can, if what's given is the obtuse angle. Yeah. So if what's given is obtuse, which is this case, you can switch to law of sines. If it's not, you can't. You might be safe, but you won't know. So for me, I tend to just stick to law of cosines when I've got it. So now I got to find angle B or angle C. It doesn't matter, but let's say cosine of B. A squared plus C squared minus B squared over 2AC. A is 12.16 squared. C was 9. B is 4. And I'm going to cosine -1 that whole thing. Angle B is 13.46. And then the last thing I need to find is angle C. So I'm just going to subtract the other 2 from 180. Oops. Oh, dang. Questions on that one? So again, I want to stress that you do have the option to switch to law of sines if the original angle given to you is obtuse. If not, you cannot. So safer to just stick with law of cosines. Either way, you're using A, which is rounded, so there's no avoiding it. All right, and then 3 is find the area given the side length. So this is AAA area, side area, or Heron's area. S equals A plus B plus C over 2, and then area equals the square root of S times S minus A times S minus B times S minus C.
So you put it to the requisite area?
No, because you don't have an angle.
Heron is for cosine. And then
It's not really for cosine, it's just for side, because you don't need cosine. It's just for side, so they group it with the cosines.
or side angle side?
Well, no, you have to have side.
Okay.
Yeah.
And everything else?
Side angle side's actually the oblique one.
Wait, when,
1/2 AB.
yeah.
Sine of-
everything else is the oblique one.
Yeah, you'll get 2 sides and the included angle.
Okay.
Yeah.
When would we use another area?
When you get 2 sides and the angle. So if you get side angle side, you use the one that was in 6-1. 1/2 AB sine of C, that one. It's on the quiz review. So I get 2.5 plus 10.2 plus 9 divided by 2, and my S is 10.85. Remember that even if that has 3 digits, you do not round it. So I'd get 10.85 and then 10.85 minus 2.5, 10.85 minus 10.2, and 10.85 minus 9. Yeah.
Will that ever be more than 2?
It could be 3.
Oh, you said to keep the whole thing.
You don't round it, right?
For S?
For S. Like this question should be so easy. Now we round it. 4, 3, 7, and yet every year somebody rounds it and gets it wrong. So don't round it. You don't need to write the unit squared, but if it was area, that's obviously what it would be. Yep.
For the one on top, the angle is 9, or the side angle is 9.
Yeah.
So for log cosine, it would be they're all different letters.
Right.
And then
They're all different for both cases. Side, 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 they're all different, but they're all lowercase.
yeah.
And then side, angle, side, they're all different, 2 lowercase, 1 capital.
So for both of them, they'll be
All 3 letters. Yep. Questions? Okay, so I want to go over at least one of those law of signs where it's an ambiguous case, so we're going to do that together. So again, quiz is 8 questions, 2 straight up law of signs, and there's no pictures on those. Like there's no pictures on the law of signs or law of cosines. You might get a word problem with a picture, you might get a word problem without a picture. I tried to level off the difficulty between the classes and stuff.
Where's the quiz review?
The quiz review is a separate assignment, but that's not this. This is just an example.
Oh, it's not on campus.
No, I literally, yeah, no. So the law of signs, which is like A over sine of A, B over sine of B, C over sine of C, and you can group those in any 2, obviously can also be flipped, but we tend to I always just use this first one just as a matter of habit. Just know that you can see it the other way. If you ever if you go to the internet and you Google law of signs extra practice, you might see something worked out that way. It's the same thing. And then we're going to do, I'm telling you this is an ambiguous case, but you have to go into it assuming you won't know, which is these law of signs, I would say definitely draw and look at. Law of cosines, maybe you don't need to, but law of signs, you definitely want to. So if I had angle A was 30 degrees, side A was 7, and side B was 5, I would want to draw that out. I would say A, B, C. A is 30. Side A is 7. Side B is 5. So I've got 2 sides and the non-included angle, and that is your ambiguous case scenario. So you're going to remind yourself that there could be a second triangle here.
Only happens in side angle.
Correct. The other thing we got for sine was angle, angle, side. Those don't have an ambiguous case. Yep.
But what if you mapped it wrong?
Don't do that.
No, but what if where you put the C, I put the B, I put
Oh, that doesn't matter.
But then I would put the 7, it would have been side angles.
No. Then you did something wrong.
So then how do you?
Like you're saying, what if you put what? Tell me how you set it up.
I never know how to do that, and I always do something random.
Well-
Like let's say I put the 30 on the left.
Well, you gotta give me letters first, though. You want to label it first. So you're saying put A here?
Yeah. So I don't understand okay, so how do you, is it always A, B, C, like clockwise?
No, it could go the other way.
It doesn't matter like this.
You just label it
As long
and
as
then you
you-
put it
And then this is 30. No matter what, that would be 30. Opposite that is what's A. That's what's important. Always 7, 7. And then opposite the capital B is where you put lowercase b. That's 5. That's 5. In both of these scenarios, it's side, side, angle. No matter what order you put those, it doesn't matter. But if you place them after you put the letters, which is what you want to do, that will always give you side, side, angle, if it's supposed to.
only possible to have a second triangle if it's side equal.
Correct. Or angle, side, side. Yeah, yeah. I just don't write that in front on the thing and get giggles. Yeah. Okay, so now I'm going to find, again, I've got one complete ratio because this is sine. So I'm using the A's here. A and side B are true for both triangles. That doesn't change. So I'm going to list everything I need to find as so I need B1, I need C1, and I need side C1. And then I need B2, C2, and side C2. You have to put the angle symbol in front of your angles when you go to give an answer. B, I could usually tell the difference, right? Although sometimes we use capitals as lowercase at this point. But C, there's no differentiating that. So when you're giving me the angle, I'm not going to mark you off if you don't put the degree symbol, but you have to write angle in front of the letter C when you're giving me your answers, okay? All right, so now I'm going to find B. So I'm going to do A, which is 7, over the sine of A, which is 30, equals B, which is 5, over the sine of angle B, 1. I cross multiply 5 times the sine of 30 equals 7 times the sine of B1, and I divide both sides by 7. So 5 sine 30 divided by 7 gives me sine of B1 is 0.357, so on and so forth. I'm not going to round it. I'm going to second sine, second answer. So I keep it as accurate as possible. I get B1 is 20.92 degrees.
For that one, can you put sine -1 and then put the...
Yeah.
Wait, how do you do that?
The negative all the way on the bottom. So second A and S. You're welcome. Yeah.
Immediately after this, you subtract B1 by like 180 minus B1.
Correct. So I figure out what B2 would be by doing 180 minus what I just found. Because that's the supplement. Good. So if there's a second triangle, B2 on that second triangle is 159.08. Now I go back to the first triangle. Next thing I want to find is C1, angle C1, and I do 180 minus the 30 I was given at the beginning, minus the B1 I just found. And I get 129.08.
You could have subtracted them, right?
Yeah, that's what I did.
Oh,
Yeah,
sorry.
that's okay. And then the last thing I have to find from the first triangle is side C1. So I'm still using the A because that's I know right. Sine 7 over the... So 7 over the sine of 30 equals, I need to find C1 over the sine of angle C1, which is 129.08. Now we cross multiply. 129.08. And then divide by sine of 30. This is when I cursed the bell ringing a minute early. Sine 30. So C1 is 6.80.
You have to put parentheses around that?
No.
What do you do for angle?
So then I go to the second triangle. Angle C2 is 180 minus the angle I'm originally given because that's for both, minus B2.
But couldn't you have done that right when you got
Sure, and then you'd know if there's a second triangle from then. If this number is positive, I have a second triangle. If it doesn't, if it's negative, I do not. So now I have eliminated the second triangle because that last angle is negative. Okay? The quiz review, I think, has one of each. One with 1, one with 2, and one with none so that you can practice them. Please, please, please take the time to complete it.
Can you publish another assignment that has like
Ooh.
more second triangle?
Well, the quiz review has it.
But the quiz review only has 2.
2 questions?
2 second triangle ones.
So as soon as you realize it's not law of cosines, I would label it 30 degrees, 5, and 7. This is side angle, so I have to test for the second triangle. This is going to be one of the 3 cases. No triangle, woohoo, you're lucky. Most likely not going to happen. 1 triangle or 2 triangles. So I know I'm missing angle B, and I'm going to call it B1. I know I'm missing angle C. I'm going to call it C1, and I'm going to call it angle C1. And I'm going to call C1 the last side. And then I'm going to test to see if there's a second one. So angle B1, angle C, angle B2, angle C2, and C2. So the one complete ratio you have is the A's. That's what I'm going to use every time I use law of sines because those A's carry over to both triangles. So I'm going to say 5 over the sine of 30 equals, the next one I have information about is B, so 7 over the sine, and we're going to call it B1. And then we cross multiply. And divide. And I'd get 7 sine of 30 divided by 5. And I get the sine of B1 equals 0.7. So I second sine that 0.7. And I get angle B1 equals 44.43 degrees. And then I start my second triangle so that I remembered to check for it. So I'd come over here and I'd say B2 would be 180 minus what I just found. So 180 minus 44.43 would be 135.57. Now you can go ahead and check for the triangle, that second triangle now by finding if there's a C2 that's positive, or I can flip back to triangle 1, finish it, and then go back. It doesn't matter what order you do that in. I eventually have to do both. So I'm going to move on to C1. C1 is the last triangle in the first, the last angle in the first triangle. So I can subtract it from 180. 180 minus angle A, which is 30, which is on both triangles, and B1, which is 44.43. 180 minus 30 minus 44.43. And I get 105.57. That's C1. Sure. Then I want to find the last side, so I use the A's again. 5 over the sine of 30 would equal side C1 over the sine of 105.57. Cross multiply. And then divide. So C1 is 5 times the sine of 105.57 divided by the sine of 30. And I get C1 is 9.63. So that's it for the whole first triangle. Remember, you would find it's no triangle like all the way from the very first angle. At the first angle, you'd get something that's bigger than 1, and then you go to second sine, it doesn't work. So that's when that would happen. Now I've got to see if there's a second triangle. So I'm going to go to my second triangle. I'm going to take the 180 to find angle C2. 180 minus the 30 that's given to me at the beginning, minus the 135.57 I found. And I get 14.43. So there is a second triangle. If that angle was negative, I'd be done. There's no second triangle. If that angle is positive, like this one is, then I know there's a second triangle. So then the last thing on that second triangle is side C2. I still use my A's. So 5 over the sine of 30 equals C2 over the sine of angle C2, which is 14.43. Cross multiply. And then divide. 5 sine 14.43 divided by sine of 30. And I get C2 is 2.49. So the answer to this question is all 6 of these. Remember to check for your ambiguous case. Yeah.
So for sine, what are the other triangles that can be side, side, angle?
What do you mean, what are the other triangles?
You said there was like angle, side, angle.
Angle, angle, side is also law of sines, but it's not ambiguous case. The only one that's ambiguous case is side, side, angle.
Okay.
Yep. So there's 2 law of sines, one with the 2 angles, so it's not ambiguous case. One with 2 sides where it would be ambiguous case. Then you get 2 from law of cosines, one side, 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 one side, angle, side. You're going to get 1 area with the 1/2 AB sine of C, and you're going to get 1 area of the Heron's area, and then 2 word problems. So there's 8 questions total. We don't need to work through these because we're going to run out of time, but this is also in 6-1 was the first type of area. So I would memorize at least one of these. It's 1/2 the 2 sides times the sine of the third angle. So 1 of each letter is here. And this, I would say, should be an easy gimme question, and at least one person every year does the wrong trig function, so be careful. The only area that used a trig function used sine. Heron's formula doesn't use a trig function.
Oh, because you have to do the
It's side angle side, but it's 1/2 the side times the sine of the other angle.
Oh, but you have to use sine.
You have to use sine. Yep. So if I was solving this kind of triangle, I would use law of cosines. But if I'm finding the area for it, I use this, which is sine. So this would be like 1/2 5.2 times 6.4 times the sine of 120.5.
So this is still law of cosines, but
No, it's not law of cosines. It's the type of triangle you use for law of cosines, but you're not solving it, you're finding the area. So this was in 6-1, just because it's sine. Does that make sense?
yes, but side angle side is like
Right. So if I gave you a side angle side triangle, you would solve it. Why do I keep not hitting sine? I would solve it using law of cosines.
right.
Yep. 3, 4. Okay, that would be that area. The word problems are like from both sections. So there's a couple of review questions for practice. You do want to know, obviously, you know all those formulas. You need both of those top two were on the warm up. But from the word problems, you want to make sure you know bearings and the properties of the parallelogram. Remember bearings like north, whatever degree, east, that kind of thing. And then the property of parallelograms that were in, like we used them in the homework, opposite angles are congruent, opposite sides are congruent, diagonals bisect each other, and consecutive angles are supplementary. Those are the 4 properties. And you'll see there's like a practice problem on the quiz review for you to do. So if you didn't finish that triangle, the real world triangle assignment, you need to finish up whatever it is and then make sure every single person submits that. And then the quiz review obviously is super important. Make sure you're practicing with the calculator you're going to use so you're not fumbling through using of the calculator on Monday, okay? Like if you look at a parallelogram, one after the other as you move around in either direction, this one and this one add up to 180. Or this one and this one add up to 180. Or this one and this one, or this one and this one. So one after the other as you move around would add up to 180. So if this is 60, this is 120, this would be 60, this would be 120. The opposites are going to be congruent, so these would always be congruent. But also these in a row will always be supplementary. And then the sides are going to be the same, right? So like if this is 10, this is 10. If this is 20, this is 20. And the diagonals bisect each other, meaning that these two would be congruent and these two would be congruent. So like if you got given, which I think is one of the practice problems, if you got given like the whole length of the diagonal, you would cut it in half to get to those 2 smaller ones, that kind of thing. All right, so on I think it's on this one. The quiz review is on Canvas. Okay, the solutions are already there. It gives you in the directions, so don't get a false sense of hope because they're going to get grouped together. It does say use law of sines for these, and then those are going to be on the quiz. No formula will be given to you. And make sure you know how to find the degree, minute, second notation. And for these, know how to make sure you would be able to get it back into degree, minute, second notation if it's given to you. So remember, if like in this, it said 55 degrees and 15 minutes, that the answer for the other angles are going to also have to be in degree, minute, second notation. So you're going to get whatever it is in decimal form, and then you do that little arrow DMS. Okay? If it gives it to you in degree, minute, second, you have to give it back in degree, minute, second notation. For the angles. Not for the sides, obviously, because sides don't have degree, minute, second notation. But for the angles, you need to. Questions? Everybody's good? All right. The formulas are in the directions on the quiz review. They will not be on the quiz. There's no formulas given on the quiz. Okay, so don't get that false sense of hope. Rewrite it as many times as you need to. I posted the link to a Quizlet. If you're a flashcard, you want to see the visual stuff. I posted a link to the Quizlet that literally just goes through all those, like law of cosine and law of sine, and then the Heron formula, and then the oblique one. guys use law of cosines for these, and then it gives you the area formulas. None of those